And then finally in free, that is the part that we're trying to set up. So free still sets the allocation bit to 0 to say that now this block is not allocated, but then it calls coalesce, which is the interesting part. Coalesce has to deal with those 4 cases, and those 4 cases depend on whether the previous block is allocated and the next block is allocated. So we start out by getting that information from our current payload pointer. If we have to change any sizes, then it'll also be handy to have the size of the block that we just freed, so we'll also get that. And then because it's useful in certain allocators, coalesce is going to eventually return the block that's now the first one, now the one that represents a freed, perhaps coalesced set of blocks. If we're in case 1 is where we just freed this block, and the blocks before it and after it are still allocated, then we don't do anything. We just return BP as it is, and there's nothing to merge. Case 2 is the first interesting one. That is where we've just freed this block. The one after it is unallocated, so we need to merge them. The way we merge them is we take the size of the next block, add it to the size of the current block, and set that as the size of the current block. So that's what we're doing here, getting the size of the next block, adding it to the current block size, resetting the current block to have that size. And because we're changing a size, we also need to change it in a footer. Again, the order of these assignments is important. We have to set the size of this block pointer to be 9 so that we correctly find the new footer for the block size. So subtle and easy to get wrong by getting those out of order. Note that the middle of this block, this now unallocated block, still has some 5 and a 4 in the middle. It doesn't matter. For unallocated blocks, whatever garbage is in there is just fine. All that matters is that we set up the header and the footer to be correct and consistent. Case 3 is where the block we just deallocated is after an unallocated block, so we need to do something similar, but it's the previous block that will become the new representative, the new unallocated block. So we sum the sizes up, and then here I am setting the size on the footer first. So we can get to the footer still and change that to be the larger value, since that's still going to be the footer of the larger block. Then we can go back to the previous block's header, set its size to be the sum, and then finally we go back, we set going back P to P. The last case is where we have 3 unallocated blocks in a row that we need to merge, so we just add up all the sizes. We set the header overall first, and then we can set the footer. That's what this line does, and then we set BP to be the previous pointer. Again, the order is chosen in a way that works out here. Finally, to make this all work, we need to make sure that whenever a block is freed, it's valid to go backwards. And if an application allocated a block and then freed the very first block, if we didn't do anything else, then our coalesce would try to go backwards to a -1 block that doesn't exist. So to avoid that problem, we can just make init allocate a kind of sentinel, a prologue block that will never be freed, and that way free is only called in blocks that are between the prologue block and the terminator block. Note also that setting the terminator block, marking it as allocated, that choice made it easier on coalesce. So coalesce can look forward. It doesn't have to care whether it's a terminator or not. It just sees an allocated block that it shouldn't merge. I've put all this code together in coalesce, where we just have all of those pieces. The overhead is bigger now. We have headers and footers. We have next and previous block. We have this extra bit in init that creates the prologue block. Extend and Malloc are mostly unchanged, except we have to set the sizes of footers as well as headers. The same in set allocated, and it's free now calls coalesce, which has those 4 interesting cases. And let's double check to make sure I haven't messed it up. Coalesce and run it through our checker. Then it works. Okay, still slow because even though we're coalescing blocks, it's still starting from the beginning every time.